Okay, and welcome back to the tutorial. Uh, we've got our new asset folder over here. We've got our enemy one. We have got our player. You can easily preview it over here. Nice. So actually, let's start creating our player. So let's just go ahead and cancel this. So to create our player, we want our area to the node. Basically, one of the reasons we are using this area to denote is uh, we don't want uh, like physics in our game. Like the main idea of the game is like just move around, shoot people. The people will be coming. Don't shoot the enemies. Sorry, the enemies will be coming towards you, and you have to like shoot them basically. And so the idea is like if you and the enemy collides, your health reduce, so you have to avoid the enemies. You can shoot them, but at the same time do not touch them. So that's how we want the game to go. So but if you actually want the player to collide with the enemy, we are not going to be using the area 2D. We are going to be using like maybe the character body 2D node, but for this tutorial we are going to be using the area 2D node as the root of our player. So let's go ahead, hit create, hit F2, rename it. Let's name it player and nothing. Create our player, yet we still see nothing in our 2D space. So what are you going to do right now is, first of all, we are going to save. You can click the scene button over here and click the save scene, or you can click we've already been shown just like the library sprite. The shortcut for the save scene is Control S. So let's go ahead and hit Control S. So our how Godot save a scene file is using the .tscn file format. But instead of hitting save directly, we are going to create another new folder. Like what you actually want for your game is to keep things as highly organized as possible. So for now, let's go ahead and rename this new folder scenes. So this is where we are going to put all the scenes in our project. This is where we are going to save them. So let's go ahead and hit save, and now we have a scene over here. A little bit of an aesthetic stuff is you can actually set a color for each folder. So I'm not a fan of this this feature, but some people provide, if you like, different color. Oh, I've got this color for my scenes folder, I've got this color for my assets folder, I've got this color for my scripts, and so on like that. So you can easily change the color by going over, by right clicking, choose the set folder color and click any of the color over here. So I'm not a fan of this, as I've said earlier, basically. So we've got our player, but nothing. Don't forget what I said earlier, that if we actually want to just display an image on our 2D space, we are going to use the sprite 2D node. But actually right now we are going to do something a little bit different. We are not going to be adding a sprite 2D node. We can use the sprite 2D node for the functionality that we need, but for simplicity of this tutorial we are going to be using animated sprite 2D node. Let's go ahead and add it. This is animated sprite 2D. So basically we are seeing a lot of warnings over here. First, the root has a warning which is this node has no shape, so it can collide or interact with other objects. Consider adding a collision shape 2D or collision polygon 2D as a child to define its shape. We'll come back to this later, but let's fix the one for animated sprite 2D first. A sprite frame resource must be created or set in the sprite frames property in order for animated sprite 2D to display frames. So what this means is that we've added our node as the child of player, but it's not just going to display a sprite on the 2D screen. We have to display we have to configure all the animations. That's why I'm not using the sprite 2D, because for animated sprite 2D we can add as many animations as we want more easily compared with sprite 2D, which is basically just to display image on our 2D space. So let's click the animated sprite 2D, go over here, click on the animation. On that sprite frame, we want to create a new sprite frame. Click on new. So we are given this new doc, obviously. So what we actually want to do is to add a new animation. You can use this button over here to duplicate, to delete, and to autoplay an animation. You can use this autoplay unload. You actually want to leave this on so that our animation is going to loop. Don't forget that we have an animation for our player already, the breathing animation, where the player goes up, goes down, goes up, goes down. So let's go ahead and rename go ahead and rename this from default to I do. So and we are going to create a new animation. We've already created the animation here, but no images at all. So if you actually have not a sprite sheet but single image like player 1, player 2, you can just drag it over here. But we don't want it to look like this. We don't want this. We want one frame at one time. Sorry. So we are going to delete that. So this is for the animations, and this is from the frames. You can see over here, this is animation, this is animation frames. So if we delete this, we are going to delete this I do, but if we delete this, we are going to be deleting our animation frame. So to add the player animation, click on this add frames. So let's navigate to the folder for our player. If you look at our player very well, you can see that there are two frames for it, in the vertical, in the horizontal, sorry, and the vertical we have just one. And good, let's click on this. This is our first frame and this is our second frame. Let's add it, and now we can easily play our animation. And there you go. This is a little bit slow actually, so we can change the animation speed over here to like maybe 8. Okay, that looks so cool. Because this is pixels, you can see how the engine tries to blur our image, which we don't want. We want it to look like this. We don't want it to look like all this blurry stuff. We don't want anything. We don't want it to be blurry. We want it to be blocky. So to do that, let's just click on the project setting, and let's go under rendering over here. Just click on the texture. You have this canvas texture. We have the default texture filter. Let's change it from the linear to nearest, and we can easily close it, and there you go, fixed. And we have our player. Okay, so you can already see that now we don't have the warning that we got earlier. To make a node feasible or not, you can easily click on this icon. Also, if you notice very well, if I click on this icon, we are getting a notification here that we have a one change. So if you go over it, you can see that this actually changes the visible over here. So this is like a yes or no. Do you want it to be visible? Yes. Not visible? Yes. And basically that's it about it. So there are a lot of different properties over here that we go over into in later, maybe later courses, but for now let's just leave it at this. So let's go over the second one that says about the shape. So everything in our scene that basically we actually want to be able to detect, because this is our player, want to detect when maybe other nodes enter it or are overlapping with it, like the player. Like we want we want it so that when the enemies are colliding with the player, we are getting a a guide that shows that the enemy is now colliding with the player. But the engine wants like a collision shape so that it will know that okay, this is the area that the player is. So basically that's what an area 2D is. It must have a collision shape. It's not even compulsory that this has an animated sprite 2D node, but it's very compulsory that it has a collision shape 2D. So let's go ahead and add it. Let's search for collision shape 2D, and we are getting yet another one. A shape must be provided for collision shape 2D to function. Please create a shape resource for it. So to create a shape, you can already see over here we have this shape, create new, and these are the pre-configured shape. If we actually want to create our shape from scratch, we can also do it, but let's just go with the circle shape, because our sprite resembles a circle the most. Let's just make it a little bit small, like that. The reason why this is small and not big is because you actually want your game to be friendly. You don't want it to be that hard or difficult for players. You want players to be like, no, the enemies shouldn't be able to shoot at me, but now the enemies are shooting at him because uh, the collision shape is just as big as this, which is not very cool. Even this is not cool. You want your game to be friendly. You want it to be forgiving, very very forgiving. So let's leave it at this and save. Ctrl S to play our scene, the player scene. This is a scene. Don't forget, we've already discussed about this. Collection of nodes is a scene. So this is the root node. This is our child, a child of the player. This is also a child of the player. So collision shape 2D over here and animated sprite 2D, they are both siblings, if you can call them that. So this is basically some basics about trees. So I'll leave a link to more explanation on trees in the video description if you would like to check that out. So to play our scene, you can just click the play icon over here, or click the F5 button, or you can play the current scene which actually we actually want to do, or we can easily click F6. And there you go. Okay, this isn't actually what we wanted. So why are we getting this? Actually, we don't want this to be like embedded game. We don't want it to be this to be toggled done. We want it to be like this or that. Also, we don't want it to be embedded on play. We don't want that, basically. So let's just click anywhere over here. Let's pause the play and let's play again. And there you go. This is our game. Game. But let's notice something over here. We are not seeing the full uh, player. Why is that? Well, the reason is because this is where this camera start to see things. This is basically the origin of our 2D space. And let's zoom back a bit, and you can already see this tiny, I don't know if you can see it on, but if you are following along, you already saw the like a small rectangle on the 2D space. This is what we are actually going to see when we run our game. So basically that's why we are not seeing the full character. So for now, we've successfully created the basic structure of our character. So the next thing we are going to do is to add a script, because for now, when we want our character to move, when we click the arrow buttons, but now if I click the arrow button, I'm getting nothing. Let's go ahead, click on the player. You can easily click on the attach script over here. At the same time, you can click on this script button over here. So I want it to inherit from area 2D. We want the language to be Godot script, and let's choose a location to save our script file. So create a new folder, name script, and create. Okay, now we have a basic text editor, and we can easily edit our player file directly from here. If you are used to like maybe VS Code, you can easily use all this text editor stuff, but I won't recommend it because there are a lot of helpful features over here, like auto completion that I just got right now. So you are not going to get that when you are using external text editor. So let's go ahead and write code for our player. First of all, don't forget I made mention of vectors earlier. So what you actually want to do is like, we want, when we press the left button, we want to deduct the player's S position so that it moves like this. When we press the right button, we want to increase the S position. When we press the Y button, we want to like the up button, we want to like decrease our Y position. And if we press the down button, we want to like we want to increase our Y position if you press the down button. So actually do that with ease, we are going to be using vectors, since the position of our character actually consists of two data. We have the X coordinate of our player, we also have the Y. So let's say that we are working in 3D spaces, we can also include the Z axis, but for now we are working with a 2D object. So let's go back. You can easily click on you can easily go back to the script and tab over here. So let's just click on script, and every time a node is enters every time a node is visible on when we are running our game, when a node is visible on the screen or enters the tree of the root scene, the ready function gets called. So a function, let's just say like a function executes, like performs an action. So a function is a little bit different from properties like the x and y position of our object is a little bit different. So function just executes whatever is in there. So it executes all the code in here. And I also want to like quickly explain something. If a function won't have anything to do, if it doesn't have any function, or you like maybe you add something to it later, you can easily add the pass code over here. You can easily just add the pass so that the Godot and the engine can easily recognize that this function has nothing to do. It executes nothing. It performs nothing. So, but we're actually going to do something over here. First of all, what you are going to do is like let's firstly delete all this function already. Let's start creating variables. To create variables, we use the var keyword. So var variable name to equal some value. So basically that's how we create a variable. First of all, we want the die variable. Die is just short for direction. I want it to be a vector too. The reason why we are creating a direction is because we want to be adding something to the position, and we need a vector too, so that when we are moving up like this, let's say we press the up button, we want the vector y position to be positive, to be negative, and when we are moving down, we want the vector's y position to be positive. If you are moving left, left over here, we want the vectors x to be negative. When we are moving right, we want the vectors x to be positive. So that's why we have a direction, which is a vector. For performance sake, you can easily add the type over here by using the double colon and just pressing the type, which is vector 2. So first of all, we have to make some changes. This our game screen is a little bit too huge. We don't want that. So let's go over to the project setting. So we are going to go under the window. We can change the viewport width and the viewport height directly over here. We want it to be 640 times 320. And we want the stretch mode to be either canvas item or the viewport. I'll stick with the canvas item. We want this aspect to be keep. So basically that's everything about the project setting over here. So let's close it, and now we are going to use another inbuilt function just like ready, which is called every time a node is a scene is added to, like basically a node is added to the root of our scene, of the current scene that you are viewing. Basically, enter and ready just means that this node is currently active. But for the process is actually called 60 every 60 and 60 times per seconds. So in games there's actually this thing called a loop. So that's what the process function is. It gets called again and again and again and again and again. And actually that's exactly what we want, because we want to be constantly checking if the player presses the left button, the right button, up, down, so that we can perform actions based on what the player did. So to demonstrate this, first of all, we are going to change the position dot x. Don't forget the position is a vector, so we are getting our x value of the position and we are changing it. We are incrementing it by plus or this plus or minus just is the same thing as saying equal to something plus something, equal to position dot x plus something, but the shortcut for it is just plus or equal to. If you are not very good at JavaScript, I recommend watching a basic beginner tutorial. So we are going to be incrementing our x position with delta. This is just for example. So what is actually going to happen is that our player is going to move right. Okay, okay, actually our player is moving, although it is very 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 slow. Let's just it things up a little bit. Multiply by 6, that should be fine. And there we go, our player is finally moving. And now we don't want this. What we actually want is like we want to check if the player is pressing, if the person playing our game is pressing the arrow buttons. So if the player is pressing up, we want our direction, sorry, dot x to be positive. If the player is pressing up, we want our direction dot y to be negative. If he's pressing down, the down key, we want our direction dot y to be positive. If he's pressing the left key, we want our x direction dot x to be negative. If he's pressing right, we want this to be positive. So we can use the Godot built-in input system. Like we can easily check if he's pressing left, up or down, stuff like that. But what we actually want to do is we want to bind two keys together. So some player prefer using WASD, while some prefer using the arrow keys. So we want it so that we don't want to be calling if we don't want to be checking if the player is pressing W or if he's pressing the up arrow key. So we want to bind those keys together, which we can easily do with Godot engine. So let's go to project setting. Let's go under the input map, and this is where we can set our inputs. So let's go ahead, add a new action. Let's call this up, and ensure if you are using like Godot 4.0 to 4.3, the decimal over here is probably 0.5. You can easily reduce it to 0.2, or you can just click it over here and press the 0.2. 0.2 is way more better than the 0.5, but it's up to your choice. Obviously this is your game, and if you feel like 0.5 makes sense more than 0.2, just go with it. So to add an event, because we basically want it so that this up is bind to two keys, which is W and the arrow, the up arrow. Okay, so let's go ahead and add an event. So you first of all we want the up arrow key, then we also we want the W. So you can just repeat the previous step. So we want the done action. Let's add it. Then and that's it for our input mapping. And well, before we actually end things, we want it so that the player can shoot. We obviously want another button for that. So to shoot, um, let's just use like the X key for shooting, and let's close it. First of all, we need a constant variable. Constant variable are variable basically that you don't want to change. You can't even change their values. So let's just make the speed 100, because actually we don't want our player to be that slow, because we want it to be we want our player to be a little bit fast. So using the by multiplying the position, the small increment that we are adding to the position by the speed, it will boost our player movement a bit, so that the player can move a little bit faster than it was before using ordinary the direction. So what we actually want to do now is to set our direction to equal to a built-in. If you are used to like classes basically can have methods, they can have property. So the same analogy also applies to the Godot engine. So we have the input classes, the input class that have the get axis method or function, and now wait, we don't want the get axis, we want the get, I think it's get vector. Yeah, we want the get vector. So the get vector, what we are going to pass it in is that what it needs, first of all, what we move this negative x, the positive x, then we have the negative y, then we have the positive y. So let's go ahead and do just that. The name that we are going to put in here must match our input map that we defined earlier. So left, right, and there you go. Now we have a direction that basically is keeping the record of our input. And now what we actually want to do right now is to add the direction to our sorry, I'm thinking to our position, go to our direction, multiply by our speed, the factor, multiply by our data. The data just ensure that the movement is consistent across all devices. So let's go ahead and run our scene. And there you go, there you go. This is not very cool, although first of all, congratulations to us for making this basic player movement already. And this is very 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 great. So but it's still very slow, very very slow. So let's juice it up a bit, maybe 400. Okay, that's a little bit too much, but I think I like it. So we leave it at actually maybe like 250. And before we stop all this, we actually want to do something. We want to keep our previous position. Mhm. Why are we going to do that? Well, that's because we actually don't. We want like a smooth transition between the position, the new position, and the previous position. So to do that, just follow along, because what we are actually doing is we are making our previous position to be the next position. So our position is now going to change to that next position using the lap function. So lap function from position, this is where we want the smoothness, to the pref position. I don't think I think let's call it next position, not pref. Next position. Yeah. Next position. Okay, yeah. Last argument, just add like maybe 0.5 for the weight. Don't want it to be that much. Okay, that is a little bit more smoother than if you are not using lap. Basically, okay, let's keep it at 300. Okay, well done. We've successfully created our player, and now we are going to create our new scene, which is, let's create the enemy first, because we actually needed to tie the game all together. So just like before, we are going to create a area 2D, rename it, oh sorry, enemy, save it, enemy.csn, yes. And I'll meet you in the next section where we create the enemy scene.